Hello all, welcome to the video lecture series for the subject compiler design. Now I'm going to explain you people about a topic called bottom-up parsing. So we have already seen a topic under bottom-up parsing, that is shift reduce. The second most important algorithm we have in this bottom-up parsing is operator precedence, right? So here you can see what exactly the operator precedence does, right? It is basically we can call this operator precedence is not a usual algorithm where you can find a number of procedures of parsing has been taken, right? So here you need to concentrate on rules where you need to apply, where you need not to apply. So that is a part, right? So here it is also, this operator precedence is also called as a shift reduce parsing, right? But here we are going to look upon the different grammar which is not performed in shift reduce parsing, right? So always this grammar in operator precedence has two properties. Number one is no RHS of any production. That is, if you have a epsilon value after a terminal term, for example, a tends to epsilon, then we cannot call this particular grammar, this particular production as a valid production. And second valid production, second not valid production. So if a tends to capital S, capital A, so you cannot find these types of grammar adjacent. We need to we can call this as adjacent, that is non-terminals or adjacent here. These types of grammar is not performed in operator precedence, right? So one by one I'll explain you so that you can able to understand how exactly this process is working, right? So here these all the steps to solve the operator precedence, right? Number one, you can see here, first part is compute leading and trailing. This is the leading and trailing. It is actually more similar to your first and follow technique, but here we are going to follow some rules, and that rule has to be adopted and it has to be matched with any given grammar, and that grammar has to produce with leading and trailing, right? The second most important thing is compute precedence relation value. Here also we are going to have four different rules and we are going to perform this, right? The third option is we have to construct a parsing table, and number four is input string parsing, and number five is precedence graph and mapping table. So this fifth part is new here, so I'll explain you how exactly it works, which you cannot able to see that in the previous approaches in top-down parsing technique, right? So let me take you directly to this part. The first rules, what we are going to find here, it is, as we have already discussed, we are going to check what is this particular leading and trailing. For this leading and trailing, we have rules to be followed. Number one, here you can see that a capital A terminal tends to, this is a non-terminal tends to a terminal. Small a is a terminal, capital Y is a non-terminal, and capital A is a non-terminal. So if this kind of production, if you find in any given grammar, then you need to find this L stands for leading, leading of capital A. So here it is, this is the production. So leading of capital A is equal to small a, right? So this is the rules to find the first terminal term in leading, right? So let me take you to the next part in this. If you find a grammar like this, if you find a production like this, A tends to, here you can see the next part, A tends to capital X, small a, capital Y. That is, a terminal term is present in between the two non-terminal term. It can be an operator, it can be anything, but we used to call it as a terminal part, right? So it can be plus, minus, equal to, divide symbol, whatever it is. So we are going to call it as a terminal term. So if you find anything like this, then leading of capital A, that is a production you have, leading of capital A is equal to small a. That is, we are going to check and find out only the terminal term in the right hand side. Left hand side, you are going to take only the non-terminal. So as I already told you about, right? So what is the third rule permits here? You can check it over here. What is the third rule here? It is, if a non-terminal in the left hand side points a first non-terminal in the right hand side. So the third rule is not pointing the terminal term. X small x is a terminal term. We are not finding a terminal term here. So we are checking only a non-terminal term. That is leading of capital A is equal to leading of capital B. Right. So these are all the rules. We are going to apply that rule so that you will have a clear-cut idea how exactly the rule has been applied to any given grammar, so that we can able to understand. Right. So here we have found what is leading. That is three rules are there, and trailing. Right. These two different properties we are going to use for step number 1 in finding operator precedence. Right. So what is rule number 2 technique approaches trailing. Right. So we have quite opposite to this particular leading is called as trailing. You can check this. This is the leading properties we have followed, and here it is trailing. So you can check it here. A non-terminal term in the left hand side point a terminal term in the last, that is right side last corner. Right. So that should be at the end. Whichever it is, that should be at the end. The finding terminal term should be at the end. So the rule properties has been expanded as this is called as trailing. T stands for trailing. Trailing of capital A is equal to small a. Right. So this is the procedure. So let me take you the next part. Next part is as similar we have in this particular leading. Right. So here you can see that A tends to capital X, capital Y, in between we have A. So trailing of capital A is equal to a center terminal term. So that is what the exact properties we are going to follow in leading and trailing. Both are equal. Here only this second property. What is the third property? You can check it over here. That is A tends to small x capital B. So first of course left hand side a non-terminal term is finding a last non-terminal term in the right hand side. So the properties has been rewritten as terminal of A is equal to terminal of B. So this is what the rules has been applied for step number 1, and we are going to perform operator precedence for this particular approach. Right. So I hope you can able to see that one more time. This is the leading, these are all the properties, and this is trailing, these are all the properties. If you find any similar process in the given grammar, then you need to apply accordingly. Right. So we are going to have, this is the example, the given grammar. You can find it over here. This is the given grammar. Right. So here you can find the given grammar as capital S tends to capital L equal to R. So all these capital letters you can see, this is a non-terminal term. Right. So all the equal to asterisk ID, these are all we can call it as terminal term. I hope you understand how exactly you can able to differentiate a terminal and a non-terminal term. Right. So let me take you to the next part here. So this is the input symbol they have been given. So the left hand side you find this is the production rule, that is a given grammar. Here it is input string. We need to take this production and we need to find exactly whether the given input string is exactly synchronizing with this particular grammar. Then this grammar is said to be a perfect grammar to derive any kind of input, any kind of similar input like this. So asterisk ID is equal to asterisk. Right. So let me take you to the first step. As you all know, what is the first step here? So the first step is find leading and trailing for the given grammar. Right. So we are going to apply the rule and we are going to find out what exactly this leading and trailing rule has been produced. Right. So now rule number 1. So here the rule number 1 we are going to check it. So what is the rule number 1? Rule number 1 is here. You can see here. It is going to find A tends to small a capital Y. We need to find the first terminal term here. So that is the approach. So we are going to check that whether we have any first terminal term in the given grammar. Yes, we have. The first terminal term is asterisk. Again, a first terminal term you can find right hand side is ID. Right. So you people can ask me a doubt like, sir, we have L tends to asterisk and R, but here it is only ID. Never bother. Yes, you need not to bother about it because we need to have this rule has to be adopted. That is a left hand side non-terminal points a first terminal in the right hand side. If this case is adopted, then the rule is exactly matching. So you need not to worry about whether we have non-terminal after a terminal term. That is after a ID, whether we have T or whether we have Q or whatever it is, right? So we don't want to bother about what is the right hand side value after a terminal term. So we got exactly this and this, right? So let me take you to this next part of it, how exactly the leading and trailing has been performed. So here you can see that the taken grammar is else tends to asterisk r and else tends to id. So these are the two different production in a given grammar I have taken, which is exactly matching with rule number one, right? So here you can see that is leading of capital L. We have L here. So leading of capital L is equal to a terminal symbol asterisk here, right? This is for production number one. Second production, L tends to ID. So leading of capital L is equal to, so you can check it, we are getting this particular ID here, right? So we least bother about after ID we have a terminal or non-terminal. First terminal term in the right hand side has to be chosen and it has to be taken and rewritten in this particular way, right? So finally we got leading of capital L. Totally, see here, this is left hand side value, you have L and this is also L. So we need not to have two different values for this. So both the leading are commonly rewritten in this way, right? So you can see here leading of capital L is equal to asterisk and ID, both together here, right? Both together has been rewritten as one single set, right? So let me take it to the next particular rule, whether the first rule is moreover matching only two different part. So whether only it is matching only with the two different production. So don't want to see much more on it. Just move on to the next rule. Which rule that particular grammar is matching? So we are going to point the second rule. The second rule is any left hand side non-terminal term has to find a center middle, that is we can call it as a terminal term. So we are going to take this particular grammar. Now you can go and verify whether this particular grammar is there or not. Yes, it is. So what is the rule we have? Leading of capital S. So here the left hand side value you need to take it here. That is leading of capital S is equal to center terminal term has been pushed over here. So that is the part, right? So this is exactly the second rule. So let me take it to the third rule. Third rule is, as you all know, you can see here, the third rule, I will scroll up. Here you can see that. The third rule is, you are going to take any left hand side non-terminal. Here it is, A is a non-terminal and B is a non-terminal. Any non-terminal in the left hand side pointing a non-terminal in the right hand side. This is the rule number 3. So in this rule number 3, you can check it, maximum number of things you can be adopted. S tends to first non-terminal L and you can check it over here. Everything is matching. Everything is almost matching. So we are going to take all this particular thing and we are going to apply the rule number 3. So first thing is we have taken this S tends to L is equal to R. So as you all know, we are going to take this first terminal term and right hand side first, sorry, left hand side first non-terminal, right hand side first non-terminal term. So leading of capital S is equal to leading of capital R. We'll have a full stop here and finally we'll concatenate and we'll write what is the final answer we are getting, right? And the second thing is L tends to R. So as of now, you please put this particular as a whole and I'll go for the next particular part because I'll tell you why I have taken this rule number 3 and applied for this, right? So the third part is you can able to take this particular thing, that is L R tends to L. So here you can check it. This third part we have taken R tends to L. So leading of capital R is equal to leading of capital L, right? So all this particular part has been over. So almost the rule number 3 has been finally done, right?
Now we are going to take this particular thing and we are need to write the final answer for this. So we have already what is leading of S, we have what is leading of F, we found all the leadings above. I'll show you something over here. So exactly we are going to see here, you can check it. Leading of L, we have a value, so you can check it here. This is the final part of it. Leading of L, we have a value, and leading of yes, we have a value. You can check it over here. This is yes, we have a value. So applying rule number 3, we need to equate all this particular thing. So now leading of S is equal to leading of R, right? So whatever the value which is whatever the value you got for leading of S has to apply it for leading of R also. So you know what is the actual meaning for this equal to. So exactly we are going to prove that, right? So now I'm going to take all this value. See here, leading of S is equal to leading of R, right? The first part. I'll take it to the second part. What is leading of R? You can check it here. Leading of R is equal to leading of L. So whatever the value you are going to get, that is going to apply for all of this. So leading of S, you know what is leading of S? I'll take you there. What is leading of S is equal to, right? So you can check it in this particular circle. Leading of S is equal to, and what is leading of R? Let me check. What is leading of R? We don't have leading of R. And what is leading of L then? So we have leading of L. What is leading of L? Yes, you can check it over here. So we have leading of L here. So we have two answers. That answers is going to be common for all the values. I'll show you how that particular thing has been happened. Now here you can check it. So here leading of S, we have a value. Leading of R, we don't have a value. For this two values has to be applied for all of this. So finally, we are going to take this is equal to is leading of S, asterisk and ID is leading of L. So this particular value now it is applied for all the leading of S, R and L. So this is the final answer, right? So now we are going to check it. What is the next thing we have? Next thing we have leading of R is equal to leading of L. So you know what is the answer of leading of L? Leading of L, we have this particular answer. What is that answer? You know very well. You can scroll up and see. Leading of L is equal to, we have two values for this. One is asterisk, another one is ID, right? So this values has to be written here. So that value is equated to leading of R. This is how this final concatenation methods has been. Union you can take, right? That is the thing I am telling you as concatenation, right? So what is the third particular part we have here? It is again we have the same thing. Leading of L is equal to leading of R. So both the thing is equal. So you can take any one from this particular part, right? So let me take you, so exactly here the leading is over. Let me take you to the trailing part, right? So now you can check it. What is this trailing is happening? You have to go and see what is the rule and apply that rule in this particular given grammar. I'll scroll up again. I'll show you what is the, these are all the grammars. What is trailing rule? These are all the rules. So the first rule, as you all know, a non-terminal in the left hand side has to point a terminal at the end of this particular given grammar. Again, second rule is common. It is going to point a terminal term in the center of the right hand side. Again, what is the last thing? A non-terminal in the left hand side is pointing a non-terminal in the right hand side last, right? This is what the trailing rules we are going to follow. So let me take you there. So now I am going to scroll down and I am going to show you how this trailing is exactly working, right? So I am going to find a last terminal term. So last terminal term here exactly. This is the given grammar. You can go and scroll up and check. Else tends to ID. So this is exactly matching. This is actually matching for both. One is first, another one is this is the last. This is actually first and also this is actually last, right? So this grammar is suitable for both. So the rule number 1 has been applied here. You can check it. Trailing of L is equal to, so you can check this is L. Trailing of L is equal to ID.
Right. So we'll move on to the next rule which is applicable, right? So the rule is, as we all know, that this rule is going to point a center terminal term in a given grammar. So the given grammar, you can scroll up and check. We found this particular grammar is exactly matching for rule number 2 in trailing. So that is, left hand side non-terminal term is pointing a center terminal term here. So exactly you can find it at terminal, that is t of, that is trailing of s is equal to, right? I hope you understood this particular part. It is common for both leading and trailing. This rule is exactly common, right? So then second part in this rule number 2, you can check it. We have exactly one part here, that is center, exactly where this terminal terms are exactly beginning. Right now here you can find it, else tends to this star and r, sorry, this star, that is a terminal term, this r is a non-terminal term. Now you have a bit doubt in your mind, that is why this particular grammar is called for this rule, because we are finding only the center terminal term, right? So absolutely a doubt is a very valid doubt, but let me tell you how exactly this rule is matching for this particular grammar, right? So else tends to asterisk r. So now it is going to find the mechanism here, it is going to find after a terminal term whether we have any non-terminal after that, then this particular asterisk will be called in this particular rule. I hope you understood. Now this particular rule has been enhanced and it has been applied for this particular grammar, that is protection in a given grammar. So I am taking this trailing of L, here it is, trailing of L is equal to asterisk, right? So we'll move on to the rule number 3. Rule number 3 is, we are going to take all the non-terminals value in the left hand side, that is non-terminals value in the left hand side need to point a non-terminal at the last in the right hand side, right? So this is what it is. So it's very simple to assemble this particular rule number 3. So trailing of s is equal to trailing of r, number 1. Again we have one more thing, that is the last. This is, I told you already, this is first and also this is r is called as last, so it is applied for both. So s tends to r, so trailing of s is equal to trailing of r. You can see that the enhanced part here, right? So we move on to the next part here, that is next third grammar, sorry, third protection rule in a given grammar, that is leading. Here it is, you can find it, leading of capital L is equal to the last non-terminal term, sorry, trailing of capital L is equal to trailing of capital R, right? So one more protection, given protection rule we have in the grammar, that is L tends to, sorry, R tends to L. Here you can see R tends to L. So in this R tends to L, again it is matching, that is trailing of R is equal to trailing of L, right? We are going to see, is there any other protection, is there any other protection is exactly matching in this particular grammar? No. So this is what it is, right? You can cross verify and cross check also and scroll up and we are going to check it, right? Now finally we are going to rewrite it in the same way where we did in leading, right? So we are going to take trailing of s is equal to trailing of r. So whatever the values we found for trailing of s will be applied for this r. Whatever the value we find for trailing r will be applied to this particular s. This is the basic idea. Now I'll take you to this particular part, that is trailing of s. You can find it, whatever the value you got it for trailing of s has to be applied over here. Now you can check it, trailing of s tends to equal to asterisk and id. I'll show the first example so that the rest of the part you can able to understand. Now see here, applying rule number 1. So let me, now here what is this s tends to, that is trailing of s is equal to trailing of r. So we are going to check what is s here. So trailing of s we found equal to number 1, right? So we have first value and trailing of yes, okay, so only 2 here, no, yes, only 2 here, right? So now you can check it, trailing of S is equal to trailing of R also. So we are going to check whether R have some values or trailing of R have some values. No, we don't have any values for this particular R. So we have only one part, that is trailing of S is equal to equal to. So this particular part, exactly this. So then how we have been derive this with all this value, that is we are getting instead of, I mean, except equal to asterisk and id is also there. How does this happen? So let me show you. Now see here, after this trailing we found two part, that is trailing of l is equal to id. Again we have here trailing of l is equal to asterisk, right? So let me take you there where we can able to identify this trailing of l is equal to r is there or not. Yes, it is. You can see here this particular trailing of R is equal to trailing of L. Again, trailing of L is equal to trailing of R. So any values you found in trailing of L will be applied to trailing of R. So you know very well what is trailing of L. The trailing of L values you can able to see here. Trailing of L value is number one is asterisk. Again, one more thing we have id. Trailing of L is equal to id. So any value you have in trailing of L which is going to apply for trailing of R also. So we got this particular thing, that is asterisk and id. I hope now you understood, right? So in the same way we are going to do this trailing of L. So here you know very well trailing of L is equal to trailing of R. So here you can see that it's very simple now. Trailing of L is equal to trailing of R and trailing of R is equal to trailing of L. Both the values will be same. Now you can see that over here, that is asterisk id or else id asterisk, right? So this is the final part. We have got the answer here for this particular trailing and leading, right? So after finding this trailing and reading, we are going to move on this step number 2. This particular algorithms are really big, right? So I have subdivided all this videos into 3 or 4 part. So you need to watch all this video so that you can able to understand that particular operator's precedence in a very effective way, right? So let me take you to the step number 2. So again we have a rules here, right? So what is that rule? Rule number 1 for step number 2 is precedence relation. We are going to find all the precedence relation here. It's very simple. If you remember all the rules, then it is quite simple, right? So now listen here. This rule number 1, we have two part. Number 1, you can find here, that is here you can find dollar, anything which is matching like this. Dollar, this symbol is called as leading and this symbol is called as trailing. That is, you can call it as I mean less than dot or whatever it is. This symbol is called leading symbol and this symbol is used for trailing symbol. You can remember that less than dot a or else greater than dot, whatever it is, dot greater than, right? Right. So if you find anything or else this rule has to be applied for all leading of S and all leading of trailing of S. S means the starting state. I'll tell you how exactly it is, right? All the starting state have to apply this particular rule. So that is the first part, right? So I will teach you the first rule and I will apply this in that grammar and we'll move on to the second rule so that you will be happy listening in this particular way, right? So I am going to apply this particular rule here. Here it is. This rule has to be applied for all the leading of S and all the trailing of S. You can ask me why this non-terminal call S alone, because S is a starting state in a given grammar. I'll show you where this S is exactly present. I am scrolling up so you can see where this S is a starting state. So this is a given production, S is a starting state. That is the reason this particular rule is applied, right? So I will scroll down again. Now I'll show exactly this rule number 1, how this rule number 1 is working, right? So I am taking all the leading of S. What is leading of S? I'm scrolling up. So you can check it over here. What is leading of S? So what is leading of S? Leading of S is equal to asterisk and id. So these are all the things. So for all this leading So for all the leading of s, we are going to apply that rule, right? So remember this, and then we are going to apply the same thing here. I'm having this particular circle so here it is, right? So we are going to have this particular leading of s and leading trailing of s has to be applied according to the rule, right? First we'll move on to this leading of s. Remember this dollar leading symbol a. This a stands all the input symbol, that is equal to asterisk and id, and this dollar remains same. This is the rule, so I am exactly taking the same particular part. So I have taken all the symbols here. You can see here leading of s is equal to asterisk and id, right? So here this dollar will be remain common, so dollar leading symbol equal to, first input has been matched. Second input, again dollar leading symbol id. We have three inputs, right? So we need to equate all this with that particular dollar. If you have only equal to here, I'm going to stop here, but we don't have equal to alone here. We have equal to id and asterisk, so we are going to take all this and we are going to match it. So dollar leading symbol asterisk, right? I hope you understood exactly how this leading is performed. Same way we are going to have this trailing. I am going to take what is trailing of s. So if you scroll up and see, if you rewind the video and see, so we have trailing of s is equal to symbol id and asterisk. All this is a terminal symbol, right? All these values are all terminal symbol, right? So in this trailing, you can check it over here. This symbol, that is this input, will be, we used to call that input as b, and this dollar will be in the right hand side, right? And the symbol, you can see this symbol is used as trailing symbol. Okay, so now we are going to apply the same thing. So here all the input is called as, here in leading, all the input we are going to call it as small a, sorry, all the input we are going to call it as small a, and here all the input in trailing, all the input we are going to call it as small b, right? So we are going to do the same operation here, right? Apply the rule. Now this dollar will be presenting in the right hand side, so equal to, that is the first input here, equal to the center symbol is called as trailing symbol. Here it is, right? So this equal to trailing dollar, again second thing id trailing dollar, again the third thing is asterisk trailing dollar, right? So applying all this particular rule number one only for the starting symbol. That's why I told you I am scrolling up. So that's why I told you this leading is for only start and this trailing is only for start symbol. So that's why this s is called here, r and l is not called, right? That is the rule. Let me take you to the second rule in finding precedence relation. Second rule here, you can check it over here. If a given grammar a tends to, that is a non-terminal tends to a terminal and a non-terminal, then we need to perform a leading, right? This is number one. Second thing is, if any case, any given production rule, any grammar the production has in this way, if a non-terminal in the left hand side points a non-terminal, first non-terminal in the right hand side, then we need to have a trailing, right? So all this is okay, but in which way we need to do? So here it is. So if any rule, this particular rule is matching with the given grammar, then x is called as the symbol which is applied there. I'll tell you exactly with any given grammar which is matching there, right? So x leading a is called as input, x is called as the value which is present in that particular grammar, right? Here it is reverse opposite, that is trailing. We have b here, right? That is the b, we used to call it as input, and that is the terminal term, and x is called as the value which is present in that particular grammar, right? So I will take one matching example for this particular rule so that you can able to understand how exactly this rule 2 in precedence relation is working. I am scrolling down. So applying this particular rule number 1, we have just now we have seen. So applying rule number 2. This is a little tricky. You need to concentrate much on here so that you will understand how exactly this rule 2 is working, right? Now here you can check it, rule number 2. So this is rule number 2. What we are going to take, if anything which is matching in this particular way, then we need to find leading. That is, a left hand side non-terminal points a terminal and a non-terminal. This X is called as a terminal and B is called as a non-terminal. This is non-terminal and this X is called as terminal. Here it is, right? This X is called as terminal, right? So which grammar is matching? Yes, it is matching. That is, S tends to L is equal to R. So you can see, rewind the video and see, this is the given grammar. We have a grammar which is matching. This is called as most nearest match. So here, left hand side, I am pointing this particular rule here. So I have rewritten that rule in the top of this particular production. See here, A tends to X is called as this equal to and capital B is this particular R, right? So now if any rule, any production rule is matching in this particular rule number 2, then we need to perform leading. This is the rule. Then how it should be performed? Now see here, S tends to L is equal to R. This X now will have the value called equal to. Here it is. X will have the value called equal to. This A will have the value called R. Sir, how do you have this X and A? I'll scroll up and I will show you. So exactly what is this? Here it is, right? So I will show you exactly here. If this particular way, any given production is there in a grammar, then you need to perform this, right? This X you need to apply and this A you need to take, right? So X is called as, here it is already present. This B we are going to replace that into A. So now I'll scroll down to this particular position, right? Okay, so now we are going to have this leading of B, that is leading of R, right? Since we are going to we are finding leading, so we are going to take this R. So we need to take what is the leading of R. We know the value and we have this value leading of R already, right? So what is leading of R? We have the leading of R is equal to asterisk comma id, right? Now we know the value for X and we know the value for small a, right? This small a is called as this B, right? This A resembles all the terminal symbols inside this particular R. So that is way it is resembled, right? So let me take you and rewrite the answer for this. I am applying the leading now. So here you can find, so now I'll write this particular symbol also here. So this is the rule. You can check it. X leading A. What is A? A, you know, this is A. This asterisk and ID is A. Okay. So this A is here and we are going to write it. What is that? The A we are going to take, X we are going to take it. What is X here? X is equal to, we have two input symbols here, you can check it. One is asterisk, another one is ID. Sir, how you are saying this X is equal to? We have already seen that X, I have already mentioned this is X. We have a value called equal to and this is A. That is, we have a value called leading of R. The below value we can check it, right? Below B what we have R. So what is the leading of R? We need to take a leading of R for this. So leading of R we have already have the values, right? So leading of R is equal to asterisk comma ID. So this B, remove this B and all the values inside this R will be taken for A. So in this way, if you apply this particular rule, the rule is what? X leading A. X is equal to, okay, X is equal to, you can check it there, X is equal to, and this small a is asterisk and this small a is ID. Okay, so we'll move on to the next exact matching part, right? So what is the next exact matching part for this particular symbol? We are going to find again any grammar which is matching with this particular thing, right? So we are finding L tends to asterisk R, right? So this is also another grammar we can able to perform leading symbol, right? So now what we are going to take it, we are going to take the value of X. The value of X here is a star, that is asterisk, and value of small a is, again we found it is r. So what is r? We are going to take this leading for this particular r, this leading for this particular r. So leading of r, we know what is the value already, here it is. So we know what is the value for leading of r. So leading of r has been taken here. Two symbols we have, one is asterisk and id. Now what is x here? X is asterisk, and leading of r, first symbol is asterisk, and leading of r, second symbol is id. So the x will be repeating for two different times over here, right? So what are all the possible match for this particular rule? We are going to take all that rule and we are going to apply here, right? So let me take you to the rule number 2 in precedence relation. Rule number 2 is what? We are going to take the terminal term, non-terminal term in the left hand side, that is pointing non-terminal term in the right hand side, right? So is there any match like this? We are going to check it with that particular rule. We have this particular grammar at the first, right? This grammar is we can see this grammar in leading also, because it is matching. See here, a is s, capital B is L, and x is equal to. So this is called as the nearest match. So we have this nearest match, so we are going to perform a trailing symbol here. So here we are going to take this L as small b and this x as equal to, right? So what is the rule? As you all know, we are going to apply exactly the same. Now the rule is b trailing, here you can check it. This is a symbol. You need to be very careful in finding this particular symbol. B trailing x. What is x? X is equal to. What is b? B is below this b you have a non-terminal called L. So what is trailing of L? We need to take it. The trailing of L we already found, right? The trailing of L is id and asterisk. The id is here, asterisk is here, right? So now the b value will be id and b's value will be asterisk. What is this equal to? That is the value of x. The x is called for 2 times because we have 2 values here, right? So this is how this particular operator relations has been made, right? So this is the second most important step. Let me take you to the third step. This step is quite simple. We are going to check what symbol, if you are matching, and we are getting what symbol, whether it is leading symbol or else it is trailing symbol. It's very interesting and very simple also. This parsing table is very important for the next step, right? What is this parsing table is all about? See here, we are going to check if we compare all the inputs, all the terminal terms, whatever the terminal terms you got in this output has to be written. So what all the terminal terms? I am scrolling up and I am checking what all the terminal terms we have here. See here, we have dollar, we have equal to, we have id, we have asterisk. Other than this, if you find any symbol that is terminal term, you can rewrite that here, right? So I have taken all these things, I have rewrite here. You can check it. First thing I have written asterisk, second is equal to id and dollar. These are all the 4 symbols we have totally have in all the above steps, right? So I am going to take in x and y axis here, right? So I am going to take x, that is x is all this value, this is y, and this is x value. So I am going to compare this x value with y value and I am going to find what symbol I am getting, right? So I am getting this leading symbol here. How, sir? How exactly this happens? Let me tell you. I am going to find, so this is the match, okay? Remember this. I am going to find star and star, okay? Star and star. What is the symbol I am getting? So you are going to check here. First thing here, you are going to check star and star. No, there is no star and star. Right? Scroll up and check whether we are getting any star and star. Yes, we are getting a star and star. As you all know, this is a leading symbol, right? If you find a star and star here, this is the way you construct this third particular parsing table step. So star and star, we are getting a leading symbol. Okay, right? I'll show this particular row, and all the other symbols are very usual for you. You can able to do it by your own. So I am going to find the second step, that is star. First step is star and star, that is leading symbol. Now I am going to check star and equal to, right? Let me scroll up and check star and equal to. Yes, here we have star and equal to. You can check it here. What symbol we are getting? This symbol is meant for trailing, right? So this trailing symbol has been taken here. It's very simple. Now I'm going to check. First thing I have been checking the star and star. Second thing is star and equal to. Third thing is star and ID, right? Let me take it to where we can find star and ID. Okay, so scroll up, here it is. So star and ID. So the symbol you can find here, it is leading symbol. That's great. So let me construct this particular table. So star and ID, we got leading symbol, right? The last part here, it is star and dollar. Okay, so what is star and dollar? So go up, star and dollar, where we find star and dollar. Okay, up, here it is. So you can check it over here. Star and dollar is present here. So star and dollar, what symbol we are getting? This symbol is called as trailing symbol. Here it is. So this is the way you are going to construct this step number 3. So here star and dollar is giving us a trailing symbol. So we are the same way we need to find this equal to and asterisk, equal to and ID. So what is this E? E stands for error. That means, so let me tell you this E, because you have never found E in the first particular row. So now we have a E here. Here it is. E in the sense I am comparing equal to and equal to, and I am not getting any kind of symbols for this particular thing. There is no matching symbols. If matching symbol is only two, one is leading, another one is trailing. If you are not finding any matching symbols, then kindly put it as E. E means error. That's it. Okay. In the same way, we are going to do this ID and dollar, all this particular thing, right? So using this particular parsing table, we are going to have the last step. We are going to have parsing the input string. This is what it is. So we are going to have parsing the input string. The given input is asterisk ID equal to ID. This is the last step, right? So totally we have 5 steps, but exactly up to here your part is completely covered. So I am stopping exactly over here. So step number 4, we have parsing input string. The given input is asterisk ID equal to ID. So I hope you remember the part where I explained about this particular input, that is shift reduce parsing. The same technique we are going to use here. This will be very simple. So I am using this input string here. You know very well what is action, and you know what is stack. If you want to recollect all this information, you can watch the video what I have been presented already for shift reduce parsing, right? So we are going to take all these things, and the input string is given in the grammar itself. You can scroll, you can rewind the video and see. You can check it. Asterisk ID is equal to ID dollar. This is given in the grammar itself, right, with the input string. So now I am writing this particular dollar symbol in the stack, that is the starting state. Again a dollar symbol in the input string. We need to have dollar and dollar matching. That means all the input string has been passed. Okay, so we need to pass all the input string, right? First I am going to compare. So here I am going to compare dollar and asterisk. How this can be really happen? Yes, exactly, I will show you this. So how exactly this happen, right? So little bit upper, yes it is. So now you can see dollar, exactly we need to match only stack with the input. Okay, not anything else, only stack. Whatever the value you have at the first value has to be compared with the first value in the input string. So dollar will be compared with star. So what is the value we are getting? Dollar is compared with star, we are getting leading. If you are getting a leading symbol, then you need to shift. Okay, remember. Yes, so we are comparing this to, and we are getting the symbol as this, that is a leading symbol. If you are getting leading symbol, then you need to shift. What you are going to shift? You are going to shift the first value, whatever it is compared, has to be shifted to stack, right? I'll show you the next step so that you will understand how exactly this particular part is working. So now you can see here this particular asterisk has been shifted to the stack. Here you can check. Now I am going to check again what. So we need to have a inputs here. We need to have a terminal. Only terminal in the left hand side in the stack will be compared with the terminal in the right hand side first value. So now you can check it. That is what is that? Dollar with ID, right? So if you compare this dollar with ID in the above table, we are getting this symbol. So as you all know, this is a leading symbol. So I told you already, if you are getting leading symbol, we need to shift. So again, I am shifting. That is, this ID has been shifted. You can check it in the second part, right? So the ID has been shifted. So let me scroll up and tell you how exactly this has been getting reduced. Now see here, this ID is compared with this equal to, right? This ID is compared with this particular equal to. Now when this ID is compared with equal to, in the above table, you check it, this particular symbol we are getting. What is that symbol? This symbol is meant for trailing. Trailing in the sense we need to reduce. So these are all the two basic things you need to remember. If you are getting leading symbol when comparing, you need to shift. If you are getting trailing symbol when comparing, you need to reduce. That's it, right? So now we are reducing it. How we are reducing it? Let me show you. See, if I cannot delete only this ID, remember, if I am deleting only this ID, I will left this particular part here. What is this symbol? Trailing symbol. Sorry, leading symbol. Now this leading symbol, if I compare with this equal to again, I will not get any answer because no leading or trailing is compared with any inputs. We are going to compare only input with an input. So all together will be reduced. Okay. Now let me take it to the next part here. If we are reducing it, we have this particular asterisk. What is dollar, leading symbol and asterisk. Now again, we have not shifted this equal to, we have just reduced only in the left hand side, right? So the equal to remains same in the same place. Now again you check it, dollar, sorry, asterisk trailing equal to. So this is what we got from the above table. So the trailing symbol, if you are getting, anyway you need to reduce it, right? So what we are going to reduce here, we are going to reduce the whole thing, sorry, whole thing in the sense that is leading symbol and asterisk. Both the things has been reduced. Only dollar left in this stack. Now again dollar is compared with this equal to. This equal to, you can check it, equal to, when I am comparing with this equal to, I am getting all the reduction part. Okay, so I am not shifted anything here. Unless it's shifted, you cannot take this equal to into stack position, right? Now I'm comparing this particular dollar and equal to, here it is, and the value what I'm getting here, it is this dollar is compared with equal to and the symbol is leading. As you all know, the symbol, if you are getting leading, then automatically it is going to shift. Now this equal to has been shifted here, right? You can check it. Now I am going to check the next part, that is equal to is compared with ID, equal to is compared with ID. Again I am getting the value as leading here, so I am using this shifting. So ID is also shifted to the stack part, right? So let me scroll down. Now I am going to, you know very well, what is the next step I am going to do? I am going to perform again a comparison. ID is compared with dollar. If ID is compared with dollar, I am getting trailing this symbol. So trailing in the sense reduce. So I am reducing this part. Okay. Again this equal to is compared with dollar. When equal to is compared with dollar, again I am getting trailing symbol. Trailing in the sense reduce. So I am reducing it. So all of this has been reduced, right? Now what left in the stack and what left in the input? The stack has dollar symbol and the input is also having dollar symbol. So dollar and dollar matches, then this is the start point, this is the end point. So all the remaining part in between, this particular grammar, this particular input with the comparing with the grammar has been parsed. So this is the parsing technique, right? Bottom up approach. So then we can call this input string is accepted. Thank you.